Okay, so this next unit, we are going to start with rate of change. We're going to be looking at tables, graphs, equations, and we're basically looking at the rate at which something changes, obviously. So it's going to be either money or time, like the height, like this table here. We're just looking at the rate and if there is a constant rate of change. Okay, so another word for it is actually slope, and we'll get into that more later. But just think rate of change, slope, they're really the same thing. They kind of use those words interchangeably. So relationships that have straight line graphs are called linear relationships. So the word line is even in that. Linear relationships, if you can plot all the points they give you in a table, or if they give you 2 points on a graph, if you can graph those and it makes a straight line, then it's linear, okay? If it's linear, then we can have a rate of change, a constant rate of change. So the rate of change between any 2 points in a linear relationship, so any 2 points on that line, is the same or constant. So a linear relationship, if we've got a straight line, is going to have a constant rate of change. Remember, constant means same. So let's look at a table first. So example 1, the height of a hot air balloon after a few seconds is shown. Determine whether the relationship between the two quantities is linear. So that's our first step. We want to see, is it linear? If I were to plot these points as if they were coordinate pairs, if I were to plot them on a graph, would it make a straight line? And if so, determine the constant rate of change. If not, explain your reasoning. So let's look at this table they gave us. So our first column, whenever they give you a table like this, our first column is representing our x value. Remember, that's your left and right on a graph. And the second one is your y. So that's our vertical, up and down. And we want to see, to find our rate of change, we're looking for the change. Remember, the symbol for triangle means triangle. Nope, it means change. So I'm going to write it like this. So the change in y over the change in x. So that's what I'm going to look for. That'll tell me if it's linear, and that'll tell me the rate of change. So my change in y, so that means I'm going to look at my y value, the height of the balloon, and it goes from 9 to 18. So 18 minus 9 is 9, positive 9, so that's why I put plus 9. 27 minus 18, also positive 9, and 27 to 36, also positive 9. So these are all the same, so let's check our x's to see if the change in x is the same. So from 1 to 2, plus 1, 2 to 3, plus 1, 3 to 4, plus 1. So my change in y was positive 9, my change in x was positive 1. So 9 over 1, or just 9, is my rate of change, okay? And so since these were all the same and these were all the same, since they're both increasing by the same amount each time, that means it's linear, and that means I can have a constant rate of change, okay? And what that means is, looking at my y value, that's talking about the height, so feet. My x value is talking about the time in seconds. So what that means, what that 9 over 1 means, is that we're going to go 9 feet every 1 second. So let's look at the first example down here. Determine whether the relationship between two quantities described in each table is linear. If so, find the constant rate of change. So number 1, got my x value, the number of tables, and y, the cost, so money. So I want to find my change in y over my change in x, and it's always a fraction like that. Even if it ends up being a whole number, you can write it over 1. So my change in y value, I go from 10 to 18, which is plus 8, then 18 to 24, so that's plus 6, 24 to 28, plus 4. Okay, so far I see that these are not the same, but let's check our x values. So 1 to 2 plus 1, 2 to 3 plus 1, 3 to 4 plus 1, Okay, so these are all the same, but these are not. So that tells me that it is not linear. So since it's not linear, I can't have a constant rate of change, so that's my answer, and I'm done. On number 2, the x value is my dozens of donuts bought. My y value is the cost of those. So same thing, I want to look for the change in y on top of the change in x. So my change in y, I've got 650, 6.5 minus 325. I want to find the change or the difference here. And so that gives me 325. When I take 975 minus 650, I also get 325. And 13 minus 9.75 is also 325. So far those are all the same, so that's looking good. My change in x, from 2 to 4 plus 2, 4 to 6 plus 2, 6 to 8 plus 2. Okay, since these are all the same, and these are all the same, my change in y, my change each time for the y value was 3.25, and my change in the x value was 2 each time. So what I want to do is I want to reduce that down. I want it to be a number over 1. So 3.25 divided by 2 is 1.625 over 1. And so what that means is, since y value is talking about my cost or the money, and the x value is talking about my dozens of donuts. So it's saying that it's 3.25 for 2 dozen donuts, or now that we've reduced it, it's going to be we'll round it to 63 for 1 dozen donuts. So when on your worksheet, if it says interpret that, that's what it means. It wants to make sure that you understand what the table or the graph is asking you. So in this case, 163 for 1 dozen. You can also, another trick is if you're doing the same thing, I would just want you guys to understand the change in y over change in x. If you take your y and subtract your x in the table, you will get your answer. Okay? So if these are all the same, if those are all the same, then that means it's linear and that's your rate of change. Okay? You're doing the same thing, you're just doing it a little differently. So now we want to look at a graph. So that was the table. So in a graph, it is linear because I have all these points and I can draw a straight line through them. We're still looking for the change in y over the change in x. Nothing is changing. We just have a different visual representation of it. So my change in y value is the vertical change, okay? And change in x is our horizontal. Okay, so my change in y, I went from 20, from one point to the next point, I went from 20 to 40. So my change in y is 20, my vertical change is 20. And then from point to point, I went from 4 to 8. So that's 4. So my horizontal change, my change in x is 4. And when I reduce that down, 20 divided by 4, I get 5 or 5 over 1. Same thing. And interpret its meaning. So my y value represented the money, and the number of tickets was my x value. So interpreting its meaning, what that means is that since I got it down to 5, it's $5 for every 1 ticket. Okay, or $20 for 4 tickets. So 5 or 5 over 1 is my rate of change. Interpreting its meaning, basically labeling it if you can read the graph. Last one, number 4, I can make a straight line out of those points. So it is linear. And I'm going to pick 2 points and find my rate of change from those. So I've got, remember it's y over x, change in y over x. So I'm going to look at my vertical change. So I went from 32 to 24. And since I went down, it's going to be a negative number. So I went down 8, and then my horizontal change. I went from 4 to 6, so 2. Okay, so if I reduce that down, then I get negative 4 over 1, or just negative 4. That's my rate of change. If I'm going to interpret its meaning, that's telling me that my time is my y value, and my number of painters is my x value. So that means negative 4 for the time and 1 painter. So what it's saying is that for every new painter I get to help, for every new person I get to help me paint, it's going to save me 4 hours. I'm going to spend 4 hours less every one new painter I get. Which makes sense, because the more people you have painting a house, the less time it's going to take. If it's just you, it's going to take a long time. There you go. On your worksheets, there's a part B to the front page. The front page has 1 and 2, and then it gives you A and B. You guys can skip part B, okay? But on A, you're finding the rate of change, and then you're interpreting its meaning, which can be as simple as labeling it like that.